Hi everyone. So in chapter 2, we did analyze one-dimensional motion in horizontal direction mostly. So in chapter 3, we will be analyzing free fall, which is one-dimensional motion in vertical direction instead of horizontal. And later in the chapter, there is projectile motion, which is two-dimensional motion. So this video is about free fall. So I wrote these two formulas that you've learned in the previous chapter for constant acceleration motion in one dimension. The velocity is basically is given with this formula number 1, and the distance is given with the formula number 2. And personally, I follow XY coordinate system directional choices. So in a previous chapter, I used toward right to be positive, toward left to be negative for the horizontal one-dimensional motion. And in this chapter, I will be using up to be positive, down to be negative, following XY coordinate system assignments. And so to me, down is always going to be negative. I realize that some of the examples in the book is changing this assignment of down to be negative to down to be positive. It can be done. It's completely legitimate, and it makes your equations a little bit less complicated looking. However, I figured that students get more confused if you change your down direction from positive to negative as well. So personally, I just stick with this XY coordinate system assignment of directions. So let's try to do some example for this motion. Before I do that, let me say this. This vertical motion is basically created by the gravitational acceleration on Earth, which is 9.8 meters per second square. However, it's sometimes approximated to 10 because mathematically it's easier to use in your calculations. And the motion itself comes from the gravitational pull of Earth on all the objects around us with a mass. So there is this gravitational force between objects which has mass, which we know everything has a mass that we know of, at least in our daily life. So everything is being pulled by the Earth towards its center. So there is this gravitational acceleration which creates this motion of constant acceleration toward down. So acceleration of gravity is always toward down, always, it never changes direction. Only the fact that on Earth, which is mostly like a spherical thing, for a person here, down is in this direction, whereas for a person here, and sizes, of course, is so extremely exaggerated. So toward down is here. So it's basically always showing the center of Earth, okay? So so it's not really like universal singular direction, but it is singular in a sense that it's always going to be showing toward the center of Earth. So let's write an example here. Let's say you release an object, a stone, let's say, or a ball. Doesn't really matter what object you're releasing, from some height. Let's say it's 30 meters above the ground. And let's say you want to see what is going to happen after 1 second. Velocity-wise, I did this, exercise with another example in the other horizontal one-dimensional motion. So I want to do a similar one here. So in our case, because it's released, I'm sorry for my writing, but release means you don't have any initial velocity. So whenever you see that an object is being released, it means that your V0 is 0. And personally, as I said, down is always negative for me. So I'm going to write minus 10 for the acceleration and times t, which is 1 second in this case. I'm looking for what's going to happen after 1 second. So this is going to give me 10 meters per second velocity after 1 second of fall. And I want to point out here is that some student gets confused for the velocity questions that they try to write for magnitude minus 10. No vector has a negative magnitude. Magnitude is the number itself only. So in this case, it's the velocity vector, therefore it's speed is the question for magnitude, and it's 10 meters per second is how fast this object is moving, and this negative tells me it's moving toward down. So when you have these velocity questions, you have two boxes, one for the magnitude, which is the speed if it's the velocity vector, and that is basically going to be 10. And the direction is going to be downward because I chose negative to be downward and my result is negative. So it tells me that this velocity is 10 meters per second downward direction. Okay, so no magnitude can be negative once more. Vectors are defined with magnitude and direction. In physics, these signs, positives and negatives, are used for direction. So you cannot have a negative speed. You cannot have a negative magnitude of a force. Magnitudes are always positive. Don't forget about that. So this was the velocity after 1 second of this object that was released from 30 meters above the ground. So let's see the distance. So after 1 second, what is the distance? So again, V0 is 0, so it's going to give us 0 plus 1/2 minus 10 times t squared is 1, 1 squared is 1 also. So you get minus 5 meters. What does it tell me? In this case, this is actually a displacement, not just a distance, but so it's a vector as well, which we didn't talk about it that much in detail. However, this minus, again, tells you that this object had moved in the downward direction, okay? So there is no distance that is negative. The distance itself is 5, but displacement is actually a vector for the distance covered, so it needs to have a direction, and in this case, it is negative. Again, this negative tells you it's in the downward direction. Here, this is basically telling you the direction of the motion. In the downward direction, this object has been displaced by 5 meters, which is the distance it will. So after 1 second, we did after 2 seconds. Similarly, you're going to be putting 0 for the initial velocity, minus 10 for the acceleration, and this time 2 for the second, so it's going to be minus 20 meters per second. And as you can see, it's now faster, but in downward direction, so it increased its velocity by 10 after 1 second, right? And 20 after 2 seconds. That's the whole idea here. Acceleration is basically telling you how fast your velocity is increasing and or decreasing. And in this case, it's increasing by 10 each second, and it increases in downward direction. And the distance after 2 seconds that this object is going to fall is going to be square of 2, and that's going to be then minus 20 meters. Once again, it's going to fall 20 meters in downward direction. Okay. I hope this is going to be helpful. I can show you one more thing about this kind of questions, which is basically time of flight. So how many seconds it's going to spend until it hits the ground could be a question. So if your object is basically released from some height, in our case, it is given as 30 meters, right? So it could be saying, what is the time of flight? That how much time it's going to spend while it's falling down. In that case, you can use the number 2, the equation number 2, because you know the distance and the initial velocity is 0, and you know the acceleration, so you can solve for time. So in this case, let me write this here again and substitute our values to solve for time. In our case, distance is going to be, because it's going to fall downward again, it's going to be minus 30, right? This whole 30 meters are going to be used because it's going to fall and hit the ground. That's the time that we are trying to calculate. Your initial velocity is 0, and so you have minus 10 for the acceleration, and t squared that we need to solve for. And from this equation, you can see why the book is choosing downward to be positive in some of these examples. See, in that case, your negatives are going to be positive, and so you won't be bothered by it. But because both of the sides of this equation is negative, you can basically divide both sides with negative 10 and get rid of that 10. and multiply with 2 both sides and solve for t squared. So here, again, both sides of negative means you can basically multiply both sides with -1 or divide both sides with -1. You can do the same thing as long as you do the algebraic multiplication or division to both sides. So in this equation, what I find is that if you multiply 2 both sides and divide with 10 minus 10, you get 6 is equal t squared. And this gives you basically t to be if you square root both sides, you get I'm going to round off to 2 digits, 2.45 seconds. This is how you find the time of flight. Some of you might be asking if you need to be solving if there is a non-zero v0. I don't believe at this level you need to solve that. But in any case, if you come across a question like that you wanted to go over, as you can see, if v0 is not 0, you're going to have a quadratic equation where you have solution for, I'm guessing that you had seen this before. This is the quadratic equation, second degree equation that you need to solve for x, and a, b, c are all constants. And the solution for this is, there are two solutions because it's second degree, is minus b plus minus square root of b squared minus 4ac divided by 2a. So I just gave this in case any one of you wanted to go over that kind of a question. I haven't seen any question like that at this level, but at a higher level course, you do go over that kind of questions. And if you come across that kind of a question, that this is basically how you solve a quadratic equation. Here, your x's are basically corresponding to your t's. And a, b, c are just constant, can be negative or positive. But I don't believe you have any question like that in your homeworks, nor an example in the book, so it should be okay if you don't want to deal with the questions like that. I hope this will help you for your homeworks and understanding one-dimensional motion, I mean in vertical, which is free fall. If you have any questions that you want me to go over specifically, you can write me an email and let me know so I can make a video for it. Thank you.